Hello everyone, welcome to Module 7 of our Software Design and Development course. We have learned to design systems, build backends, and create front ends. But even the most elegant application fails if it contains undetected bugs or breaks under pressure. Today is about validation, testing, debugging, and quality assurance. We will cover testing principles, DDD, debugging techniques, code reviews, and QA processes. Let's get started. Here is our roadmap. We will cover the following: fundamentals and core principles of software testing, unit integration, system, and UI/UX testing, test-driven development, TDD, behavior-driven development, BDD, automated testing tools across the stack, systematic debugging techniques, code review workflows, and QA processes, practical testing workshop, and finally, we look into best practices and professional do's and don'ts. Quality assurance is not an afterthought, it is embedded throughout the development. Modules 1 through 6 give you design, back-end, and front-end skills. But professional software engineering demands more. Users expect reliability. Businesses cannot afford production bugs. This module shifts focus from creation to validation. You will learn to systematically verify functionality, isolate and resolve defects, implement automated testing pipelines, and enforce quality gates. Software testing systematically evaluates whether a system meets requirements. Seven core principles are: testing shows presence of defects, not their absence. Exhaustive testing is impossible. Focus on risk-based coverage. Early testing saves time and cost shift left. Defect cluster in complex or frequently changed modules. Test suite must evolve. The best side paradox. Testing is context dependent, e.g. elements versus financial system. And finally, bug-free doesn't mean meets user needs. The testing pyramid. Unit testing covers 70%, fast, isolated, and high ROI. Integration testing, 20%, where it verifies component interaction. And E2E or UI test cover 10%, which is the full workflow validation. This pyramid keeps your test suite fast, reliable, and maintainable. Let's dive into the first two pyramid layers. Unit testing. Unit testing tests smallest parts, functions, classes in isolation. Python example is PyTest. Integration testing validates interactions between modules, APIs, or databases. Node.js example with supersets. Unit tests catch logic errors early. Integration tests catch interface mismatches. Together, they form the foundation of a reliable test suite. Moving up the pyramid, we have system testing, which evaluates the complete integrated system against functional and non-functional requirements. This includes full workflow performance, security, and cross-browser compatibility. UI/UX testing ensures the interface behaves correctly and provides an intuitive experience. Types include visual regression, accessibility, and cross-evidence System tests verify the whole work, while UI tests ensure real users can actually use it. TDD is a methodology where you write tests before production code. It follows the red-green refactor cycle. Red means you write a failing test, while green means write minimal code to make it fast. Refactor improves structure while keeping tests green. Great calculator example in jest. TDD drives design, ensures coverage, and catches regression early. BDD extends TDD by writing tests in business readable language using Gherkin syntax, given when then. Feature example for course enrollment. Gherkin feature course enrollment as a student. I want to enroll in available courses so that I can access course material. The scenario here is successful enrollment, given I am a logged-in student and the course has available seats. When I click the enroll button, then I should see a confirmation message. Implementation with Cypress or Cucumber. BDD bridges business requirements and technical validation. Automation is essential for modern QA. Key tools are unit integration, UI, E2E, accessibility, and performance. CI/CD integration with key actions. Automated suit run and every commit, catching issues before production. Testing finds bugs, debugging fixes them. Systematic debugging workflow we produce, which isolates steps to trigger debug, observe, gather logs, stack traces, network responses, hypothesize, which formulate root cause theories, then test which modify code and environment to validate. Finally, fixed and verify, that is to apply solution and confirm test. Essential tools are browser development tools, Visual Studio Code Debugger, Sentry/LogRocket for production error tracking. Example, button stop ignore the network tab shows is. Systematic debugging saves hours of frustration. Code reviews are critical QA gates. Review checklists are meet requirements, edge cases handling, robust error handling, and security. Readable, maintainable, follow style guide, test included and passive. Pull request workflow is shown here. Then for the static analysis tools, we have linters, formatters, security scanners, SonarQube to track technical depth, coverage, and complexity. Reviews catch what test needs and spread knowledge across the team. Let's apply everything workshop scenario. Test and debug a course enrollment feature in LMS. The tasks are write a unit test for can enroll logic status, prerequisite, and capacity. Mock API responses. Write an integration test verifying front-end state update. Intentionally break token refresh and run Xcode accessibility. Add test scripts to CI pipeline for GitHub Actions. Apply the testing pyramid practice, red-green refactor, diagnose failure safely, and build confidence in shipping reliable features. Building a culture of continuous quality. Let's look at best practices in software quality assurance. Shift-left testing, which integrate QA early in requirements and design. Test automation pyramid, which prioritize fast unit tests. Continuous testing that runs suits on every commit. Meaningful metrics to track defect escape rate, MTTR coverage trends. Blameless postmortems, which focuses on system improvement. QA as shared responsibility. Developers write test, QA design strategy. Documentation as code. Maintain living test blocks alongside sources. Quality is everyone's job, from product owner to developer to QA engineer. In conclusion, today we cover the complete testing and QA landscape. This prepares you for modules 8 through 10. DevOps cloud deployment, real-world enterprise application, and launching your software engineering career. Let's get started to the next module.